So hello guys, welcome back to our channel. So today we are continue with the remaining lecture of the subnetting. Also so we are discussing about the subnetting. So subnetting means we are dividing the large network into the small pieces of network. Means this is the large network we divided into the small network in the four part. So let us consider a network. Suppose 200.200.200.0. So from the network ID, we can find it out. This is a class C network. This is a class C network. So we know that class C network ID is 24-bit and host ID is 8-bit. So if we consider it, if we divided it to the big network in and divided it big network into the four parts, means four subnetwork, then we have to common 2 bits for the subnetting purpose. If we divided it into the 8 parts, if we divided the large part is 8, so we can common it out 3 bits from the from the subnetting. So if we apply subnetting from the here, so we know that the host ID part network ID bits is being less due to the subnetting. So the network ID bit is 24, host subnet bit is 2, and host ID bits are remaining 6. Total we get as a 32 bits. Okay, so total bits are 32. This is not being change. We are changing only the subnet ID and host ID. So from the 2-bit subnet ID, so we are dividing this network into the four parts. So if this is the first, this is second, this is third, and this is fourth. So fourth part means the 2 bits are 0. So either 2 bits are 00, either 2 bits are 01, either 2 bits are 10, and either 2 bits are 11. So the subnet ID is starting from 00, 01, 10, and 11. So let's suppose this is the big network, and we divided this big network into the four part. So this is the first, this is the second, this is the third, and this is the fourth. So if we commented the subnet bit as 00, so this is 01, and this is 10, and this is 11. So let us consider that. Let us consider. So from here, so we are details discussing about the first network. So we are discussing about the first subnetwork. First subnetwork. So the network bits are the 24 bits are same, but the first 2 bits are denoted by subnet ID. So we are fixed it out as 00 because due to the first network we are fixing subnet ID as 00, and here we are defining 6 bit. So 6 bits for host ID part. Means from here we can see that first the last octet 00 is bit for subnet ID, and last 6 bits we are changing out for the host ID. So so the first ID of this subnet is 200.200.0.0 for subnet ID, and if we consider the all the 6 bits as 0, 4, 5, 6 bits 0, then we came 00, 2, 3, 4, 5, 6, and similarly 00, 1, 2, 3, 4, 5, 6, 00, 1, 2, 3, 4, 5, 6. 6 bits are all 1. So we know that the all the host ID, all the bits are 0. We are not assigning to the any of the network. So this is the network ID of the first subnet. So first host ID which is assigned to any host is 00, first host, and Also, we are known that the all bits are one. Host ID all bits are one, not assigning any one of the network. So this is also the represent the broadcast address of the network. Broad, broadcast address of broadcast address of the network. So this is the so the previous one is the last host ID. So from here we can find it out the range. So from the host ID, so if we get, so this is the range from 1 to 1, first bit is 0, so 1 to 62 is the valid host range. 1 to 62 is the valid host range, but the range of this network is lies between 0 to 63. So if this be between the 0 to 63, so if this bit is 64, so this bit is 120, this bit is 64, then apart from if we range this all the bits are 0, so we get the range from 62 to, if all the bits are 1, we get 127, and then third bit 0 1, so this is the 128, so 128 to 191, and the last subnet range is between 128 and 64. This is between 192 to 255. So these are the range of the each one of the subnet. So from the second subnet, from the second subnet, so we are not changing the network ID part. So the subnet ID 2 bit is we are fixing as 0 1. So apart from the all the bits are 6 bits are 0 if we consider it, and then 2000.01 1 2 3 4 5 6 and dot 0 1 1 1 2 3 4 5 6 0 1 1 2 3 4 5 6. So this is also not assigned to any one of the host. So this is the network ID of the second subnet, and this is the broadcast address of the second subnet, and this is the last host of the second subnet. This is the first host of the second subnet. So from this way we can find it out that this range is between the host range is between 65 to 65 to, if we consider it all once, we get 127 126. This is a valid host range, valid host range. So this is a valid host range. So from this we can get the subnetting concept. We get that, and the uh, 2 bits, two id is being wasted. So first id is wastage from the subnet id of the network, and the last id of the wastage is the direct broadcast address of the subnet. So similar way, if we divide it into the four subnet, so number of bit is wastage, number of network id network is wastage. So we can say that the, so we can say 2 key power 2, 2 key power 2, 4, 4 into 2 minus 2 means 6. 6 network id is wastage, 6 network id, because we are minusing 2 because of, if we not applying the subnetting, we are applying this as a network id of the entire network, and one is the broadcast address of the entire network. So we are considered it as 2, And apart from total, we are wastage from here is 4. We are divided it into the 4 subnet, and every subnet we are having a one network id and one broadcast address, so we are considering it at 8. So and 2 is we have actually used in previous, so 6. So 6 network id is being wasted. So if we divide it into the large number, then it will be deducted as many as possible. So for that, so this is the disadvantage of the subnetting. So later we are discussing about the each and uh, every subnet id and the every network id of the network. Thanks for watching. If you need this type of content, please like, share, subscribe to my channel. Bye.